You're talking about something the size of a star, the sun, an octillion tons of mass or something like that, getting flung away way faster than a rifle bullet.
The universe has a way of keeping secrets. And on July 1st, 2025, one of those secrets came hurtling toward us at a speed that shouldn't be possible. Edward sat alone in the control room at Rio Hondo, Chile. Coffee steaming beside him, the telescope dome open to the freezing night air. His job was simple: scan the sky, check the database, confirm known asteroids, move on. Night after night, the same routine. Until it wasn't. A notification flashed across his screen. Another moving object. Random alphanumeric designation. But something was wrong with the numbers. The velocity reading made him lean closer, blinking hard. He ran the calculation again. Same result. Again. Still the same. This thing was moving at 58 kilometers per second. Over 130,000 miles per hour. Fast enough to circle Earth in 11 minutes. Moon to Earth in under 2 hours. The fastest visitor our solar system has ever recorded. But speed wasn't the real problem. It was the eccentricity value. For anything bound to our sun, that number needs to stay below 1. This object registered over 6. Edward understood what that meant immediately. This wasn't orbiting our sun. It came from somewhere else entirely. He traced the trajectory backward. The computer painted a line stretching past Neptune, out beyond the edge of our solar system, into the dark between stars. This visitor had been traveling for an incomprehensible amount of time. Millions of years, possibly billions, gathering speed with every stellar encounter, bouncing from star to star like a cosmic pinball, each gravitational interaction accelerating it further into the void. David Jewett, the man who discovered the Kuiper Belt, confirmed what Edward suspected. An object moving this fast had to be ancient. Impossibly ancient. 10 days later, Matthew Hopkins stood before a packed auditorium at the UK National Astronomy meeting. The room buzzed with anticipation. Everyone wanted answers about this bizarre intruder now officially designated 3I/Atlas, the third confirmed interstellar object. Hopkins clicked through his first slide. A standard trajectory arc. Nothing unusual. The object would swing past the sun and exit back into deep space. Expected behavior. Then came the second slide. This one showed something different. Not just the path through our solar system, but through the entire Milky Way galaxy. The room went silent. Hopkins and his team hadn't just traced this object back a few million years. They'd accounted for galactic rotation, the gravitational influence of every star it passed, the slow dance of our entire galaxy through space. And they discovered something unsettling. 3I/Atlas wasn't traveling through the thin disk where our sun lives, where younger stars orbit in a relatively flat plane. It came from the thick disk, the ancient zone, where stars formed when our galaxy was still finding its shape. Hopkins advanced to the next slide and spoke a number that changed everything. 10 billion years. Maybe older. The room erupted with questions. How could they be certain? What did this mean? Hopkins explained calmly. This object was a time capsule. It formed around a star that likely no longer exists, and by pure cosmic chance, its path intersected with ours. We were looking at frozen material from the literal dawn of time. On July 21st, Hubble turned its gaze toward 3I/Atlas. David Jewett knew this wouldn't be easy. The object was screaming across the sky at impossible speed, 277 million miles away. Hubble had to track it like following a bird in flight with binoculars. The image compiled slowly. Noise. Static. Then gradually, pixel by pixel, a shape emerged. A teardrop. Not the object itself, but a massive cloud of dust streaming behind it. Ancient particles, frozen in ice for billions of years, now sublimating directly from solid to gas as the ice warmed. They measured the cloud, calculated backwards, and estimated the nucleus at roughly 5 kilometers across. Small, but not insignificant. And those particles they were observing? Material that existed before Earth, before our Sun, before most of what we recognize as our cosmic neighborhood. But they still didn't know what it was made of. On August 6th, the James Webb Space Telescope locked onto 3I/Atlas. Where Hubble saw shape, Webb could read chemistry. When light passes through gas, specific wavelengths disappear. By identifying which wavelengths go missing, scientists can determine exactly which molecules are present. Martin Kortner's team analyzed the spectrum and found something unexpected. This comet was hemorrhaging carbon dioxide. Not water vapor like normal comets. CO2. Massive amounts of it. The implication hit immediately. This object had never been near a star before. In our solar system, comets that repeatedly approach the Sun lose their CO2 first because it sublimates at colder temperatures than water. Our comets are water-rich because they've been baked repeatedly by solar heat. But 3I/Atlas? Virgin ice. Untouched by starlight for 10 billion years. Until now. Then, in early September, astronomers noticed something that violated basic physics. The object was venting gas. Enormous amounts. 8 times more CO2 than water vapor, one of the highest ratios ever recorded. When comets release gas, it acts like a rocket engine. Gas shoots one direction, comet gets pushed the other. Simple action and reaction. Except 3I/Atlas didn't move. Not a millimeter. Its trajectory remained perfectly unchanged despite massive outgassing that should have deflected it significantly. Only 2 explanations exist. Either this object is so massively dense that the rocket force can't budge it, which would require a density closer to metal than ice. Or something is actively maintaining its course. Avi Loeb, the Israeli-American physicist and former chair of Harvard's astronomy department, started asking uncomfortable questions. He traced the object's origin point back to a specific region, the constellation Sagittarius. On August 15, 1977, astronomer Jerry Inman was reviewing data from Ohio State's Big Ear Radio Telescope when he saw something that made him grab his red pen. A sequence appeared on the printout, 6EQUJ5. A signal 30 times stronger than background cosmic noise, lasting exactly 72 seconds at 1420 MHz. The frequency where hydrogen naturally resonates. The Universal Emergency Channel scientists theorized any intelligent civilization would monitor. Inman circled it and wrote one word in the margin. Wow! The signal never repeated. For 48 years, astronomers have searched that patch of sky. Nothing. Loeb calculated the probability. 3I/Atlas and the WOW signal originated from regions within 9 degrees of each other. The odds of this being coincidence? 0.6%. Then in early August, something stranger happened. Multiple amateur radio astronomers claimed they detected a signal from 3I/Atlas itself. Not reflected radio waves. Not natural emissions. A transmission. 11 seconds. And when decoded, it showed a repeating sequence. Prime numbers. 2, 3, 5, 7, 11, 13, 17. Prime numbers don't occur naturally in cosmic phenomena. They're mathematical constructs. They require intelligence to generate. Carl Sagan famously suggested that if we ever received an alien signal, it might be prime numbers. A universal way to announce intentionality. NASA has not confirmed this detection. They've remained remarkably quiet about any radio observations of 3I/Atlas. But multiple observers reported structured patterns repeating every 22 minutes. Loeb tasked his entire team at the Galileo project, Harvard's scientific search for extraterrestrial technology, to monitor not just the object but the space around it. He told Newsmax that if this is an alien probe, it might release smaller probes to investigate nearby planets. A Harvard professor telling us to watch for probes. October 3rd arrived with unprecedented opportunity. For the first time in human history, we had spacecraft positioned to observe an interstellar object passing another planet. NASA's Mars Reconnaissance Orbiter, the European Space Agency's Mars Express, and the ExoMars Trace Gas Orbiter were all pre-positioned to capture 3I/Atlas during its closest approach to Mars, just 29 million kilometers away. Everything was planned meticulously. Multiple high-resolution cameras. Multiple angles. This was supposed to be our best look yet. Then NASA released exactly one image from the worst possible camera available. The Perseverance rover's navigation camera, designed for driving on the Martian surface, not deep space photography. The image showed an elongated streak, 4 times longer than wide. Social media exploded. People called it a tic-tac, a cylinder, proof of artificial construction. But Loeb explained the issue. At that distance, each pixel represented roughly 12,500 kilometers. The 4-pixel streak would translate to 50,000 kilometers in length. If the object were actually that massive, we would have seen it the moment it entered our solar system. What people were seeing was a time-lapse artifact. Because the object was so faint, NASA stacked multiple exposures over 10 minutes, creating the illusion of a streak. But the real question remained. Why only this one terrible, misleading image? Where were the high-resolution observations? Mars Reconnaissance Orbiter carries HiRISE, capable of 30-kilometer resolution per pixel at that distance. That data was definitely captured. NASA blamed processing delays on a government shutdown. But if they could release the Perseverance image, why not the raw HiRISE data? Mars orbiter images typically appear within hours, sometimes days. The website updates constantly. But nothing from the 3I/Atlas flyby. Then the European Space Agency released their images. 5-second exposures showing something bizarre. No tail. Weeks earlier, ground-based telescopes had clearly observed a prominent tail. The tail was gone. The explanation offered was that a coronal mass ejection, a blast of solar plasma, had temporarily destroyed the tail. But when this happens, tails reform within minutes or hours. What if what observers saw before wasn't actually a tail at all? In early September, amateur astronomer Michael Yeager was photographing from Namibia when he captured something impossible. 3I/Atlas was glowing green. Vivid, unmistakable green light. He shared the photos immediately. Within hours, astronomers worldwide confirmed it. The comet was green. Except weeks before, Chile's Very Large Telescope had determined that 3I/Atlas was carbon chain depleted. Almost no dicarbon, the molecule that makes comets glow green when hit by sunlight. One of the most carbon-depleted comets ever recorded. It shouldn't be glowing green. But it was. Stephen Burns, another amateur astronomer, created a time-lapse animation from NASA's Perseverance images and posted it online. Other astronomers immediately began analyzing it frame by frame. They saw things nobody had noticed before. Multiple objects. Not one point of light, but several, traveling together. At the 3-second mark, a brief green flash. Not a pixel artifact. A diffused glow. Offset from the main object. Then came the polarization data. Zuri Gray's team published the first polarimetric observations of 3I/Atlas. This technique reveals what space dust is made of, its structure, its size. Every comet in our solar system produces predictable polarization patterns. Asteroids too. Even Borisov, the last interstellar visitor, showed standard positive polarization. 3I/Atlas showed what they called an exceptionally deep and narrow negative polarization branch. No comet behaves this way. No asteroid either. It was scattering light in a manner never before observed. They genuinely had no idea what it was made of. October 30th, 2025. Something astronomers are genuinely worried about. For approximately 3 weeks, we're going to lose sight of 3I/Atlas completely. As it swings around the Sun at perihelion, its closest approach, it will pass directly behind the Sun from Earth's perspective. Every ground-based telescope will be blind. The Sun's glare will wash out any possibility of observation. Normally, this wouldn't cause concern. Comets pass behind the Sun constantly. We lose sight, they emerge on the other side, we continue tracking. But 3I/Atlas is not normal. And what happens to comets at perihelion isn't always predictable. Comet Ison in 2013 was supposed to be the comet of the century. Astronomers watched it approach, getting brighter and brighter. Then it went behind the Sun. When it should have emerged on the other side, there was nothing. The Sun had destroyed it. Or Comet Lubge in 2011. It flew within 140,000 kilometers of the solar surface. Scientists were certain it would vaporize. But it survived. And emerged fundamentally changed. Its tail ripped off and reformed. Its nucleus fragmented. Barely recognizable. Perihelion is violent. Radiation pressure is crushing. Temperature swings are extreme. Gravitational forces can literally tear objects apart. 3I/Atlas will experience all of this while we can't watch. But some scientists think it might not just survive. It might activate. If this is artificial, and that remains a significant if, then perihelion might be exactly what it's been waiting for. Maximum solar energy. Maximum radiation. Maximum gravitational interaction. An object approaching the Sun. Disappearing from view. Potentially transforming while hidden. Emerging changed. The timing is making people anxious. This strange object with anomalous properties, growing media attention about possible artificial origin, and a period where we lose sight completely. The European Space Agency's JUICE spacecraft is supposed to observe 3I/Atlas in late November, right after perihelion. But that data won't be available until February 2026. 3 months to process. 3 months to decide what we're allowed to see. After all the analysis, the question isn't whether it will emerge in December. The question is what will emerge. This is potentially the most monitored celestial event in human history. And there's a reason for that. December 2025 would be the perfect time for what researchers call controlled revelation. The object has been in the news for months. The public has been slowly prepared for the possibility it might be artificial. Scientists have already introduced the idea of alien probes. If any government wanted to disclose the existence of extraterrestrial technology, this would be the ideal opportunity. They wouldn't have to admit to decades of cover-ups. They could act as surprised as everyone else. Or they could go the other direction. Complete denial. No matter what the telescopes see in December, officials could insist it's natural. Just a weird comet. And who could prove otherwise? We're watching something that could rewrite everything we understand about our place in the universe. Or it could be nothing at all. A cosmic coincidence. An ancient chunk of ice that happened to wander past at exactly the wrong time to avoid scrutiny. But the anomalies keep piling up. The impossible speed. The extreme age. The lack of trajectory change despite massive outgassing. The connection to the WOW signal. The alleged radio transmissions. The missing high-resolution images. The green glow that shouldn't exist. The polarization data that makes no sense. Every explanation leaves something unexplained. Every answer raises new questions. And in a few weeks, when 3I/Atlas emerges from behind the Sun, we'll finally know. Or maybe we'll just have more questions. Either way, December 2025 might be the most important month in human history. Or it might quietly fade into astronomical footnotes. A strange visitor from an ancient time that passed through our neighborhood and disappeared back into the endless dark. The universe keeps its secrets. But sometimes, just sometimes, those secrets come looking for us.